Hello. Sorry I cannot be here with you, but I do want to kind of make sure that you are on a good footing with writing proofs and kind of address some misconceptions that people have about, what a proof is and stuff as well. So today we're going to be focusing on how do we find evidence to be able to do, good quality proof thinking. And like it or not, we want you to kind of get out of this class good quality proof thinking so that you can learn how to make arguments and kind of understand the logical structure of how arguments work. So on your bell work today, what I want you to do is kind of go through the front page and the back of the front page, and it will kind of guide you through first thinking about what a proof is, like outside of math class. So, believe it or not, if you've used like claim evidence reasoning in English or history class, you have done some elements of proof thinking already. And then on the back page, there'll be a sample triangle proof type of situation, kind of a basic one, but we're just going to be kind of teaching you here how to read the diagrams, and I'll even have some rulers at your desk where you could actually look at things like the two tick mark sides, for instance. So the sides that have the same number of tick marks, for instance, are going to be congruent to each other, and we could use pieces of evidence like AB is congruent to XY to make an argument as we kind of build whether not triangles are congruent to each other. Okay, what we will do first is go through some of the quick notes here, and we're going to talk about the main ideas of writing proofs, and then I'm going to walk you through a few examples and the things that you might want to keep in mind when you are working on the UTRI. All right, so kind of the quick notes here. So the main idea with proofs is that corresponding parts of congruent triangles are congruent. And we have an acronym that says that CPCTC is what we'll kind of like use. So this means that corresponding sides are the same length and corresponding angles are the same measure. So this is kind of like your first main idea. And then the second main idea is kind of the game plan for writing proofs over the next few weeks. And our game plan is going to kind of be as follows. First, you're going to kind of look at given information. You want to look at the diagrams for what is given. And even on the harder proofs, there's always going to be some information that's going to be given to you. And then you want to use properties and definitions to match other things that are congruent to each other. And here's some like frequent definitions you're going to see. And you can kind of put these in your quick notes box. One of the things that's kind of common, there's these triangles that look like bow ties and hourglasses. And you might even want to trace the angles sometimes. And if you have like a color marker or colored pencil, you could actually like connect the dots and trace them and then kind of see a vocab word that might be pretty familiar. So remember the angles that looked like chopsticks, they were called vertical angles. We might also want to be thinking about things like midpoints and bisectors. So midpoint means that there's a point in the middle and it divides the line segment in half. We could use bisectors as well. We also have things like alternate interior angles. So things that kind of make those zigzags are alternate interior. And one thing that might be new that we use a lot throughout our triangle proofs are the situations where there's a shared side. And when we have the shared side, it's called the reflexive property. So AB congruent to AB. And this would be a reflexive property. And I'm just going to kind of box that because it got in a little bit of a way with the bisectors, but there we go. All right, let's kind of look at a few examples now as we are going to the next page. And we're going to kind of show you some typical types of questions you're going to see on the homework and on 5.1 mastery. We're not writing formal proofs today, but what we're kind of doing is we're getting practice reading through the diagrams. So like if we look at example 1, these triangles are congruent. So congruent means that they kind of measure the same. And we might want to kind of go through and see what matches and what's kind of the easiest. So if we kind of notice here, I have 130. That's kind of my big angle. So that other big angle is going to be 130. And I'm actually not going to really pay attention to what the question asks yet, but I'm going to kind of just focus on what it is, what I can find like immediately. Or like over here, this side is 7. And I can see that this triangle is kind of like slightly rotated. So that side also has to be 7 as well. Or I might do in another color like that 2.5. And that side would also have to be 2.5. And the 18 could carry over to the smaller angle on the other triangle. So that would be 18 degrees. And I might want to think about what is the missing angle measure. So like angle D. So I could do, for that one, I could do 180 because the 3 triangles add up to 180 for the angles, minus 18 minus 130. And that would be 32 degrees. So that angle is going to be 32, and that angle is going to be 32. And then I might look at the question and what it's asking. So it says that EF, well, I already found what that is. So that's going to be 7. And then the measure of angle D is going to be 32. And that's your final answer on there. All right, next one, similar idea, right triangles. Things like the 180-degree triangle property still work. Pythagorean theorem for the sides. Let's actually kind of just do what's easy first and then kind of work our way towards what's more difficult. So we have both of these angles here are 90 degrees. I think it's easiest to kind of like match the hypotenuses as well. So if this is 11 for the hypotenuse, then the hypotenuse of the other triangle has to be 11 as well. And then I'm going to copy the angles that kind of match each other. So 55 is over here, and we could kind of see that this is a rotated triangle, so that's going to be 55. And then I'm going to put 35 for my other angle, since the three triangle angles add up to 180. And if I want to find the missing short side, I could actually just translate this into a Pythagorean theorem problem. And this is the classic a squared plus b squared equals to c squared. So I'm going to do x squared plus 9 squared equals to 11 squared. And just kind of remember, square them out. 121. Move the 81 over to the other side. And it does not say anything about answer form. So you can kind of leave it as square root of 40, or you can convert to decimal. So I believe that would be about 6.3 or so. So you'll have some good review over some of those triangle problems, like the Pythagorean theorem and 180. Okay, finally, what we want to do is actually look at a sample way that you can argue that triangles are congruent or not. So at this stage, we just want you to get the experience of looking at matching evidence. And we want you to kind of see why a triangle is congruent or not congruent. So let's take a look. So this is the classic, are the triangles congruent or not? Some stuff is pretty obvious from the diagram. So a 1 tick mark side and a 1 tick mark side, they're going to be, kind of given. So we're going to say that AB is congruent to GF. Then I could look at the 2 tick mark sides as well. So the 2 tick mark sides, I have side AC, and that matches with side CF. They are congruent to each other. And then I could look at the 3 tick mark sides. And my 3 tick mark sides, I have BC is congruent to CG. And we're actually going to learn in about 2 skills that that's actually really all the evidence that you need. But you could also look at the angles as well. And some angles are actually given to us. So it's important to kind of just start with the ones that are marked in your diagram. So I could say that angle B is congruent to angle G. And I could also trace the diagram here. So if I kind of look at, it kind of has that bow tie type of effect, bow tie hourglass type of effect. So I'm going to trace it maybe with a little thicker marker there. So here I go. It's nice and bold here. But I can actually see that I have vertical angles going on. So these are vertical angles. And if I know that they're vertical, I know that they are also congruent to each other. So I could say that angle ACB is congruent to angle GCF. Therefore, due to all this information, we found plenty of information to show that yes, the triangle is congruent to each other. Okay. Last but not least, I want us to kind of look at for the last some of the you try problems. I'd like you to kind of try them out first on your own. So maybe pause the video and give them a try. Question 1 on your you try is just putting in the missing measurements. Question 2 is the practice of diagram marking. Question 3 is kind of a similar to what we just did. Are they congruent or not? And if you are feeling ready to delve into proofs, question 4 and question 5 are really good places to kind of start. And I think you could actually make a pretty good dent on this. So take a pause here for a minute. All right, so here's the you try answers. Number 1, it is isosceles. So that's kind of a main idea here, that they are isosceles triangles. So for instance, if FG and EG are congruent to each other, they're congruent to each other because the angles are congruent to each other. So it has that symmetry of the isosceles triangle. And then you could use things like 180 degrees. Number 2, this is just marking the diagram. So you might want to connect the dots. So if I have like ABC and I have, GHC, I can just draw that angle. I could draw that angle there. And I put the same number of tick marks or notches. And that kind of tells us that they're the same. And I also think it's good if you see a academic vocab word like midpoint, that you define what it is and maybe think about how does that impact the markings on the diagram as well. Okay. And then let's kind of look at the next page here. On number 3, I'm kind of just looking for a bulleted list. When we get to the mastery assessment over this unit, I'll have a little chart where I might say, what line segment matches with line segment QR. But these are the things that match each other. Question 4, notice that there is a vocab word in the kind of start of the question. Maybe define what that vocab word means and think about, how the bisector divides that bottom line segment exactly in half. Also, we know that right angles themselves are congruent to each other. And we might want to kind of put star on that last thing that we have at the bottom, but the reflexive property is going to be something that you're going to see every time we have a triangle or two triangles that share the same side. And then the last question, this is especially if you're kind of like an honors, we want you to maybe be thinking about this type of stuff today, but if it's already marked in the diagram, it's given. So like KL and AL, for instance, are, congruent to each other. Ooh, sorry about that. Get back on my PowerPoint here. Not perfect, but get this paused. So we want you to kind of get the experience of, tracing the vocab words and identifying them. So, some words are a little harder to see than others. So, for instance, like ILK, or actually IKL. And let me just get that highlighter a little bit more bold. So IKL is an angle. And it kind of is matched with the angle BAL. And I connected the dots and notice that they kind of make a zigzag. So that's why it's alternate interior. Or if I'm doing the angles in the center, so I'll maybe do that in a different color. So if I have ILK, this is kind of in red, and I have BLA, that's going to be like vertical angles. And that's where we're kind of getting the evidence. So tonight's Delta Math IP is kind of just matching evidence from the diagram for most people. A few of those, applied the measurements from the congruent triangle problems. But we're also going to pull the honors to more of that, statement and reason style thinking. So if you're in honors, you are going to be on the hook for that, just as a heads up. And as always, feel free to reach out to me if you have questions still, even though I'm not in here. And you are welcome to come see me in the hall, after school, come to my office hours, and we can get you on the right track. So thank you very much.